So now that we have created the pad for the particular component, we are ready to start creating the footprint for the component. Now before we jump right ahead into creating the component, it's always better to look at the drawing which we are going to follow and then refresh a little bit of the coordinate geometry we have learned earlier, so that it makes it easier for us to draw this diagram perfectly and accurately and also very easily and fast. Now, when you are creating footprint for a component, look at your design and remember a couple of things. The component footprint which you create should always be centered on the 0, 0 on your drawing. And that means that if this is your component, then the center of the component, the body center of the component should align with the 0, 0 on your design. This is very important because later on, if you have to drag the component for placement in various places on the PCB board layout, then this design makes it easier. So for that, what we need to do is a couple of calculations, and as a matter of practice, what we would do is always choose the top left pin of the component as our reference. Now to calculate the coordinate of the top left pin on the 18-pin device which we are going to create the component for, let us see what we need to do. Now the top left pin, if you see here, you will get that the pitch between the pins, the spacing between the pins is 2.54. So if I have 18 pins in all, then each of my columns would have 9 pins, and then the length of the column from the first pin to the last pin would be n-1 multiplied by the pitch, which is 9-1 multiplied by 2.54 in our case. So let's do that. This is 8 multiplied by 2.54, I think it's 20.32, and then if we get around there, it is basically what? It is basically how much? It is 2 9s are 18. Now this is 1, then 10, and then 1 and 6. Yeah, 10.16 is your y coordinate of the top left pin, and it's positive because it is in the direction that is up from the origin. Then if you need to calculate the value of the x coordinate, the total spacing between the two columns is 7.62. So body middle would be at 7.62 divided by 2. And for the top left, it would be negative since it's towards the left from the origin. Hence that is this one, minus 3.81. So basically the top left pin coordinate will be minus 3.81 and 10.16. Now with that knowledge, let us go and see how we can translate this into the component drawing. So we would go first to layout and pins. If you have the context menu here, you would see it open up. Now since all of these pins will have wires connecting to it, we would choose the connect option. At times what we need to have are holes for fasteners to go through them, and in those cases, for those holes we would tag them as mechanical, but in most cases you can do with just the connect option. Then for pad stack, what we would do is, in general this would be empty, so we would hit the browse button and then from the list select out the pad that we had created. For us it is the one that is 4330 clock IC, and OK. Then this area here allows you to replicate your pad placements pretty quickly. So what we need to have are, in the y direction, since we are talking about a column of pins, we have to have 9 pins, so that is there. Then the spacing would by default be 1.27, but for us it is 2.54. And then the order for the left hand column is top down, so it is down. And then the pin number start at 1 and would increment by 1 value. After that, what we would do is we would come to this command line over here, and we would use the command X and provide the XY command for the top left pin, and we calculated that it is minus 3.81 and 10.16. If we do that, the software is automatically going to place 9 pins spaced 2.54 apart from the center of one to the center of the other, that's the pitch, and then numbered the pins accordingly, using the pad which you had created and you set here. Now the other column of pins is numbered bottom up, so we would change this to up, and then the pin number, of course, it's again from 10. And for the bottom right pin, the calculated coordinates just reverse in polarity. So minus 3.81 would just be 3.81 in this case, and 10.16 will become a minus 10.16 in this case. When we do that, now you have the components pads placed exactly 7.62 apart in the two columns, 2.54 between the pins in each column, and have been numbered according to the number which you would find on the IC. When you are done with this placement, right click anywhere on the design and do a done. This is something that you would have to repeat for almost all of the designs that you do. Now the creation of the part is not complete. Once you place the pads for a particular component, there are 4 other things at minimum which you need to place for this component's footprint to be a valid design. They are called the package geometry silkscreen top, then package geometry place bound top, and then we would put 2 reference designators. One is for silkscreen top, another one is for assembly top. Now when I place those in the next video, I'm going to talk you through what they are and the purpose that they serve.